This problem asks us to find the forces in each of the members that make up this truss. So if we look here, we're going to need to know the force in what I will call AE, BE, BC, CD, CE, and DE. So counting them up, we have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So 6 forces, 6 members in which we need to find the forces. Since we want to find the forces in all the members of the truss, I'm going to use method of joints to solve this, as it's going to be the most systematic way to find those forces. If only specific members' forces were required, I would consider using method of sections here. So no matter what method I was using, I would first look to see, is this structure statically determinant or indeterminate, before I draw my first free body diagram or write my first equation. And looking here, A is a pin and B is a pin, which means that I'm going to have 4 support reactions, AXAY, BX, BY. So this structure is statically indeterminate, meaning that the external free body diagram will not let me find all of those support reactions. There's 4 unknowns, but I would only be able to get 3 equations out of it. So I am going to opt to not draw the external free body diagram in this case. I am going to start already with pin diagrams. There's nothing wrong with drawing the external free body diagram, but I know that there's going to be unknowns I just can't solve for. So now I want to look at what pin do I want to start with. In the grand scheme of things, it doesn't matter as long as I can create overall a solvable system of equations. But as a rule of thumb, if I'm able to start with the simplest pins and start getting some numerical answers right away, that's going to be a good way to go when I'm solving this by hand. So I have A, B, C, D, E to choose from. What I'm going to want to start with, the easiest place to start, is any pin that's connected to only 2 members and no supports. So looking at my choices here, pin D fits that bill. It's connected to member CD and DE, and there's no support attached to it. There's an external force, but that's okay. So as far as free body diagrams, I know I'm going to need several for this one. I'm going to start with D. And all of my free body diagrams, I will say X is right, Y is up. So starting by drawing the pin at D as a particle equilibrium free body diagram. Right, so first I'm going to copy the external force that's acting on it, that 600 Newton force that is pushing to the left. I copy exactly. And now the forces in the members that are attached to it, I'm going to be assuming tension. So CD is pointing down in what I'm designating the negative Y direction, so FCD. And note with the names of forces, I'm always going to use the alphabetical notation, so that way I won't accidentally write FDC and in one place and FCD in another and not realize it's the same force. Every time I reference this member, I will call it FCD. And I'm assuming tension, it's coming out from the point D. And I also have this force coming out. I'll have it coming better out of the center here of DE. Now, FCD was along the axis. I didn't need any direction there, but DE, I do need its direction. And if I look, it's making a 3, 4, 5 triangle. If I just quickly split this up, this is an isosceles triangle, so this is going to be 3 meters, and this is going to be 3 meters, meaning that that's 3 meters as well. So I can see that it's a 3, 4, 5 triangle, a little bit hidden there, so I will use a ratio triangle to put this together. So 4 high, 3 horizontal, and 5 this way. And for D, that is my complete free body diagram. Now, I started at D by design because we see in this free body diagram, there are only 2 unknowns. And it's a particle equilibrium problem, so I will be able to get 2 equations out of this. So actually, I'm going to start writing some equations before I draw another free body diagram because I know this will be solvable. So I can solve forces in the x, forces in the y. The order does not matter, but in this case, I'm going to start in the x direction. And this is coming from free body diagram D. So I'll put a superscript D here so I know which free body diagram I'm summing forces in the x. And because the whole truss is in equilibrium, every section of it is as well. So I know it's going to sum to 0. Now I chose to start in the x direction because with my unknowns, only FDE is going to have an x component. So it's going to have 3/5 FDE, and that points to the left, which is negative, minus 600 newtons. And I can see that that's going to be solvable. So I'll wait a minute to solve it though, because I can write my second equation then. In the y direction in this picture, I will have all of FCD pointing down minus 4/5 of FDE. So I'll be going back and forth here between free body diagrams, equations, and solve steps. Equation 1 is easy enough to solve. I only have one unknown there, FDE, and solving equation 1, I get negative 1,000 newtons. And because I'm always going to be assuming tension is positive, the negative means it's in compression. So notice it is negative 1,000. That tells me it's compression, but that sign is important because, for example, in equation 2, I'm going to need to use that again. So the variables, according to the picture, it was down and to the left, so that dictated how I wrote both of these equations. So I'm going to substitute in the negative 1,000 into equation 2, and the only remaining unknown will be FCD. So FCD, I'm going to get 800 newtons, and it's positive, which means that FCD must be in tension. All right, so here I'll note one, FDE came out negative, but I am never redrawing a free body diagram once it is drawn. I assumed tension, I drew it that way, my equations were written that way. Just because my assumption was wrong, that's okay. I know it's in compression now, but I need to be consistent in how I use it. Once I assume it was in tension in one place, that has to follow everywhere else. So I was able to solve for two of my own unknowns, DE and CD. So let's just check those off. DE is solved for here, and CD as well. So just keep track of things we know, things that we don't know yet. All right, so if we look at our find, there are still 4 forces that we need to find. We've only used one free body diagram, so we can keep going. So what's our next target? We still have A, B, C, and E that we can make pin diagrams for. Again, A and B I probably want to save because they have those supports that we did not solve for yet. So C and E are the next reasonable choices. C is attached to 3 members. However, one of them we already know. We already know CD. E is attached to 4 members, only one of which we know. So I'm going to say that C is the next one we want to draw because there's only going to be 2 remaining unknowns in this picture. So it's going to be algebraically easy as our next step. Right, so point C is at the center of this free body diagram. I'm going to copy exactly that force of 900 newtons acting on it. And now the 3 members it's attached to. So assuming tension, we'll have the force in CE to the left. We'll have the force in BC down because we're assuming tension, and then the force in CD up. So notice here, FCD, this appears in this picture and it appeared in picture D. I am still assuming tension because I assumed tension in D, I'm assuming tension in C. I'm obligated to make that same assumption in both pictures it's in. Even though I already know FCD is in compression because I did solve it numerically already, I don't use that knowledge when I am making the free body diagrams or when I'm writing the equations, I'm again going to let the math work it out for me. So my picture C is now done. All three members and the applied force are there, and everything is along a coordinate direction. So I can write equation 3 now, and 4, from this free body diagram. Again, I'm going to let the free body diagram dictate the equations, then I'll substitute in any values that I already know. In this case, let's start with the x direction because there's only one unknown in the x direction. So I have negative FCE from the picture and minus 900. So only one unknown there. In the y direction, from the picture, FCD is up, so it's positive. FBC is down, so it's negative. Again here, it's algebraic. From the picture, FCD points up, so it's positive in this equation. In the solve step now, I can start substituting in values. So solving equation 3, FCE is the only thing I don't know. FCE is going to be negative 900 newtons, so it too is in compression. In equation 4, I already know the value of CD is 800, so I can solve for FBC. So it did turn out FCD was positive, it was in tension, but I don't need to know that until I put it into this solve step. So FBC also 800 newtons, also in tension. So CE and BC we now have. BC and CE. So only two unknowns are remaining. We have A, B, and E that we can still make free body diagrams from. So E is going to be the next natural choice here because it's attached to 4 members, but now when we draw it, we're going and write its equations, 2 of the 4 we already know. So it will only have 2 unknowns left to solve for. So it's going to make the algebra easier to get through, certainly. All right, point E there's no external forces acting on it, only the forces in the members. So it has member CE, which we're assuming tension because we assumed it in the other picture as well. We are going to have here the force in DE, and this way the force in AE. Both of these make 3, 4, 5 triangles. So I'll just indicate that here. 3, 4, and 5 is that angle. And finally, we have BE. And that too is going to make a 3, 4, 5 triangle. I'll just make sure it's marked here and clear. So now in picture E, those are the 4 members that are affecting it, assuming tension in all of them and no external forces. So we can move on and write its 2 equations. In this case, I'll just, the same thing I did for the other ones. Let's go in the x direction first. We have in the picture FCE points to the right, so it is positive in this equation here. We have plus 3/5 FBE, its horizontal component points to the right, plus 3/5 FDE minus 3/5 FAE. And in equation 6, looking in the y direction, we will have positive 4/5 FDE. We will have a negative 4/5 FAE, it's pointing down, and also FBE, its vertical component points down as well. And we'll be able to simplify this. We can actually cancel out those 4/5 everywhere to make this one a little bit easier to solve as we go down to our solve step. So 5 and 6 are coming from free body diagram E. Now here, unfortunately, we can't, we have AE is in both and BE is in both of these equations. So there's not a super simple way to solve this. We will have to use substitution or elimination and solve equations 5 and 6 simultaneously. It's not too hard. It's only 2 equations, 2 unknowns. It's not as easy as 1, 2, 3, 4 were to solve, but there are only 2 remaining unknowns. So if we solve 5 and 6 simultaneously, we will get that FAE is a negative 1750 newtons. So it is in compression. And the last unknown, BE, we will get positive 750 newtons tension. All right, so down here, these are the 6 unknowns that we needed to solve for. And we did it with 3 free body diagrams. We were able to do it without having to solve for those reactions at A and B. We were not asked to find them. So we were able to skip the external free body diagram and start with our pin picture. Because it was statically indeterminate, I decided to start at D and work my way down so that we could have, at least by hand, the easiest system to solve as we went along. And from 3 free body diagrams, each of them being a particle equilibrium free body diagram, we were able to get 2 equations each, 6 equations for the 6 unknowns we were interested in, and we were able to solve the entire thing. And one thing I should have checked at the beginning was, do we have any zero force members? Well, at this point we already know that we don't, but let's see if we go through the steps of identifying if we could. All right, so from pin A and B, we're not going to look at any of the members because A and B are supports. C and D have external forces acting on them, so we're not going to consider them for the zero force members. So really pin E is the only pin that we could look at and see, is there a zero force member attached to it? AE and ED are parallel to each other, so neither of them is definitively a zero force member. We cannot conclusively say either of them would be. If we look at EC and EB, they both go in a direction that is oblique to the AED axis. So EC and EB both share that direction, so we cannot definitively say, if we were at the start of the problem, we could not definitively say that EC or EB, that's BE or CE, were zero force members either. So we do already know none of them were, but there was nothing we could identify up front anyway. But it is a good idea to start by seeing, can we see any zero force members before we start the problem?